Hello friends, so let's start the part 2 of the cache fusion. Okay, so let's see how it works. So we will see using the diagram and the flow where how everything or all moving parts work. So let's say this is the database. Okay, red color, this is the block, this is a shared global area SGA. Okay, this is the memory and this is a user. Okay, so let's see the workflow. Now the user actually requests a specific block. Okay, so user process is created. Okay, on the server it's the server process is created. Listener is first used. User process communicate with the listener. Okay, listener finds out because listener has a registration of different services running on the database. Okay, so it finds out what all services user wants to request and what all services user wants to connect, and eventually the server process is created as soon as listener knows that that service is running. Okay, the server process is created. Now user communicate with the user server process. Okay, directly in the dedicated server architecture. So let's say user fires a query, select star from employee. What happens is from the database, okay, the block is pulled to the database buffer cache. Okay, in the shared global area. Okay, that is for single instance. Okay, now in the rack environment, another user connects to the database. Okay, and the user process and the server process on the server is created, and user fires the same query, select star from employees. So what will happen? What do you think? So the thing will happen is the block will be copied from the node 1 and put into the node 2. Okay, so that is called a cache fusion. Okay, in as a bird's eye view. Okay, as an overall picture. So to use cache fusion or not, when a block is requested, the buffer cache is searched. Okay, as we all know, user 1 was trying to connect. The first step will be the buffer cache will be searched. If the buffer is not found, then the database will go and find out the block from the data files, fetch it, put it into the database buffer cache, and the user will be provided the details. Okay, if not found, what will happen? Either get it from the disk, get it from the other cache. Okay, in the cache fusion situation. Okay, that's what we saw. And if it is found, then there are two options. Sorry for the mistake. Then send the buffer to the user. Either do that or examine for the other caches for the presence of this buffer. Okay, that can be done. Okay, how does, in all the situations, how does database decide which option to take? Okay, what should it do? Okay, and what action it should perform? So buffer state, as we all know from the theoretical lectures and theories, whatever I have gone through, okay, in the last hour. So buffer can be retrieved into two modes. Consistent read, we are not going for past image. Okay, so don't worry about that. So we are thinking about consistent read and current. Okay, so current can be modified into exclusive current, but that is the parent of exclusive current. So that is the current. That's what I'm trying to define here. So let's say if user has the intention to modify the buffer, then the buffer is retrieved in current mode. Okay, if the intention is to modify, this can be only one for an instance. Okay, current. If the intention is to select, the buffer will be retrieved in the consistent read mode, CR. We already know about it. Okay, there can be several CR copies in the buffer on the instance 1 and on the instance 2 accordingly, right? Each current buffer is a shared current. We already know about shared current. Okay, this can be multiple copies. Okay, and that will be similar to all the instances. Okay, and if by chance that particular shared current block is requested by specific user to modify, then that will be immediately changed to the exclusive current. Okay, and it will be one exclusive current block stamped on that particular block for the entire cluster. Okay, and there can be multiple shared current in entire cluster, as we already know that. Okay, every shared current will be identical, so shared current will be multiple, consistent read will be multiple, but the exclusive current will be only one. Okay, and that will be the latest version of the block with the latest SCN number stamped on it. Okay, remember that. So let's go through the workflow or the complete flow of it. User wants to update row 1. Okay, so now this is multi or the clustered environment, multi instance. Okay, user is sitting here. Okay, requesting, and user process is created, same thing happens, server process is created on the server. Okay, user says update row 1. What happens? Block is copied to the instance A and row 1 is changed on that block. Okay, now user 2 comes in. Okay, on the instance 2, as you can see on the right side, and server process is created. Okay, user says update row 2. What will happen now? What do you think? Let's see that. There will be cache fusion. The block will be copied, okay, from the instance A to the instance B. Okay, and the block will be updated. Okay, so remember that row 1 is highlighted in red and row 2 is highlighted in green. It is to specify that green is for instance B and red is for instance A. Okay, so that we know which instance is actually modifying which particular row. Okay, so now, so all these blocks will have the system change number. Here you can see the block sitting on the data files on the database. It will be system change number 10. The first block, okay, will be system change number 20, and the latest block with the row updated, which is 2, will be system change number 30. All the versions of the blocks will be different, and now you can see that when we have a question that if we have 1 gig of database sitting in the data files, okay, how much memory we need. Let's when management team wants to project that how much resources they want to invest, or kind of how much RAM they need, so people will think that okay, so 1 GB database, okay, will need 1 GB RAM, and we will completely put the data into the RAM, and now we don't need to go to the data files, right, to the disks to fetch the blocks, right, because everything is there on the memory. But it's incorrect, because as per the different users access the blocks, the versions of blocks keep changing. There will be different versions of the block. Okay, and as you can see in this particular picture, there are 3 versions of the same block, so you can multiply that 3 times, but actually there will be seven what do you call, the versions of the block in the real world. Okay, so let's move forward. So I am finalizing the word saying that if you need uh, uh, if you want to know amount of RAM you need for 1 GB database, that you have to multiply by 7. So 1 into 7, 7 GB RAM. So if you want to put the complete database into the RAM, then you need a 7 GB RAM. Okay, to put the complete database into the RAM, and you don't need to go to the disk to fetch the blocks. That's how much you need. Okay, that seems overwhelming, but that's how Oracle is defined. Okay, now let's update the row 3. Okay, now user wants to update the row 3. What will happen? User on the left hand side wants to update row 3, so cache fusion will be activated. Okay, and the same block will be copied. Okay, and now that block will be termed as SCN40 and will be modified by instance number A and is highlighted in red. Okay, so you see there is 4 versions of the block. Okay, SCN 10, 20, 30 and 40. Okay, accordingly. Now as per written below, version 10, 20, 30 and 40 are the different versions of the block. You can see that. Okay, so how does Oracle knows which one is the recent copy? That question may arise, right? So while updating the row 1 from the user 1, okay, because this block was the most recent block, okay, and fetched from the database itself, it will be stamped as SCN20 and will be stamped as exclusive current. Okay, this will be latest block, as we already know that whatever block termed as exclusive current will be latest block, and this particular block which is termed as exclusive current will be only one on the entire cluster. Okay, so let's move forward. Now update row 2 from the user 2. Okay, what will happen? Because the block with SCN20 has been copied to the instance B, as you can see the block has been copied. So now this SCN20 block, okay, will become consistent read. Row 2 will be updated. The system change number will be stamped as 30 because that is latest, and it will be termed as exclusive current. Okay, I hope you guys are understanding how it goes, right? Now, so SCN number is attached to the version of the block. Okay, now user 1 says update row 3. Row 3 is updated. The block is updated stamped as SCN40. Now because this is the latest block which has been copied from the instance B to the instance A, okay, has been modified, and which has the latest SCN and stamped as exclusive current. So this is the latest block, right, which will be used for the recovery purpose, as well as which will be persisted to the data files, and that the older block will be consistent read. So that's done. I hope you guys enjoyed that particular demonstration. The next will be the practical demonstration of the Cache Fusion. Thank you very much for watching. And one more thing, please like my video, please subscribe if you guys have enjoyed it. Please click the bell icon to know the latest video whenever I am posting. Okay, thank you very much.